back to part 2 of how to solve a problem like a weaving machine. If you've never seen me before, you're probably in the wrong video. You need to see part 1. So watch part 1, then come back to us, and then it'll all make sense, hopefully. So, just to recap on the last video, the arbor in that weaving machine that holds the carriage was loose. Now it's filled with this babbitt or lead. Over time, it just starts to get loose because it's backwards and forwards, and it just starts to get a bit loose in there. So, I come up with a bright idea, so I thought, is putting a seal underneath, warming the carriage up, the lead just sink into it and re-seal itself. And I thought, oh yeah, that'd be great. Anyway, I did that and it leaked everywhere. I mean, it literally went everywhere. It was a big old mess. So, sort of glad it happened, because what I've done, I've looked on YouTube, I've looked on the internet, and I can't see anything about what I've done to this. So no one, as far as I know, has done this before. There could be a reason for that, but I don't know what it is. So, watch the video, and I'll let you be the judge of it. So we've now melted it all out, so that there should be all loose. So just going to take that off now. A big lump of scale there. Probably all the rust and everything off the thing, so we'll get rid of that. Yeah, so now that has to come off. So this is the melt out, the babbitt I think it's called, that came out of there. So because it started leaking out, I've come up with another solution. We're going to glue it in. So I'm going to melt that out, clean it all up, repaint it, and let's see where we go from there. Seeing the first melting come through now. Bubbling away, so you can feel the gap around it. So with the epoxy resin, there we go. There we go. Heavy. The load is there. Right. Picking it off. See where it's all coming through. Okay, here, fully. This scabby bit here, where you see the hole is not quite in the centre. That is the original threaded end that we've got out of the ramp. And it looks like this was made originally by, all they've done is just get some stock bar, chopped it on a saw, stuck it in a lathe, faced it off, and then just stuck a drill through it. That one's been wobbling all over the place because it's oval and out and round and, you know, not very well gripped in the lathe, and then they've threaded it. Now it's worked, obviously, because it's been running for God knows how long, but I think if I clean this up, it's just a bit too scabby, and I don't like it. So I'm going to make a new one. Hopefully it will look better than that, but to be honest, it's going to do exactly the same job as that, no different. So let's make a new one. A new one. So what I've done is threaded it, which was horrible because it was a cheap tap, but it's threaded now with a 3/4 inch BS Whitworth, and these little grooves that I've put in there, staggered in, and this is when this goes in and is bonded in, it won't be able to turn because that's locked in, and the pressure under there will be tight, so it's always going to be pushed down. We're going to sandblast this just to about there, upwards, and that should help it bond a little bit better. Degrease it, and then we'll fit the thing. Just sandblasted it, so it's all ready for going in. Right, I'm going to do an experiment. I've got 3 of these rods, and I've put welds on each one of them to replicate the threaded end that goes in the weave machine. So what we're going to do is we're going to put one in here, and we're going to pour the lead that I drained out of that into there, and to see how much force we can push on that. Remember, this is molten metal, always. There we go. Now the problem with this, and this is why I want to change it, is because when it cools down it shrinks, and it shrinks a lot, so it doesn't actually stick to the steel. So when it's actually in the hole, this is why you have to heat up the whole lot so it compresses onto it. And this is why I think this causes the problems. Now with this, I'm going to use this, the epoxy resin. And what I'm going to do is fill one of them with just pure epoxy resin. Put one of these rods in, see what happens. This one, we're going to use the epoxy resin, we're going to use a fire blanket. Now a fire blanket is made out of fiberglass. Now I've cut this into 2-inch strips. It's not the easiest to chop because it runs the scissors because it's fibre. But if you get close enough, you can see how it just all pulls apart. Can you see that? Quite therapeutic. So all you do is just pull it apart into strands, and that we're going to mix in the resin, because that will bond it all together. Whatever's got the least in, which is that one. That's where the fiberglass is going to go in that one. So this one, I can put that in the centre there. There's that one. Now this one, we're going to mix this in. to do now, so we can bury that thing into it. Now that already feels a lot more stable than the other one. What I'm going to do is put a heat gun on this, and this, just warming it up, we'll get rid of the bubbles. See where it goes around in there? See, the bubbles will probably come out a lot easier on this because it's just pure resin. And here, there's probably going to be a lot of air bubbles. When we come to the end of part 2, there was only going to be 2 parts to this video, but now there's going to be 3 because there's so much footage to cover. And I did want to show you the 3 mandrels that we've set, one in lead, or the babbitt, the other one in fiberglass, and the other one in resin. So on part 3, we're going to test them to destruction. So we're going to explode, basically. And what that's going to give us is the worst possible scenario that when they're fitted in there, if that can happen, it won't. But it will just show which is the best or suitable for the job. So hopefully in part 3, you will see it finally finished, and then you can see if you'd want to do something like this, or just get someone else to do it. Who knows? Anyway, thanks for watching. Part 3 will be out soon.